Anyway, so now that we know how to count in binary, we can cover the IPv4 classes, which we discussed in a previous vlog, I think, and blog post, probably. I do distinctly remember talking about A, B, and C. Now, type A being 4. Yeah, gosh, that's bad. That is bad. Why am I writing it out in decimal? We just covered decimal. I don't want to confuse you. Plus, I already have the subnet masks written down. So ignore this. I'm going to erase that. Subnet mask. This pretty much tells you what the network is. So the first octet is an A network, okay? Like I said in the previous one, that's your 192.0.0.1, whatever. B is the first two octets, 192.168.0.0. And then type C is like 192.168.1.0. Then we talked about the hosts. Now, the different classes, you can identify what the classes are by how they start in binary. A type A network ranges between 1 to 27. So, a type A network, let's say it starts with 10. 10.152.63.5. These don't matter. We don't care about the last three. We're just looking at the first one. So 10, what is 10? Okay, so we can look back up here and we can just find what the lowest number is, 8. Okay, so 10 minus 8 is 2. We have to go back up here and we have to say, okay, 2. 2 minus 2 equals 0. So counting with binary, you're kind of wanting everything to cancel out to 0 if you're trying to convert decimal to binary. We have our initial decimal number. Okay, then we have to find the highest digit that fits inside of that and subtract it out. That gives us a remainder, and then we do the same thing with the remainder. We find the lowest digit that will fit, and then we subtract it out until we reach 0. So what does this number look like in binary? Well, 10 decimal is going to equal 00001010 in binary. And if you look up here, this is how we know. We didn't use 128, we didn't use 64, 32, 16, but we did use 8. And where we did use an 8, we would change that to a 1. And then we didn't use 4, we would change 2 to a 1 because we used 2 and we didn't use 1. You can add that back up. 8 plus 2 is 10. 8 plus 2 is 10. It's all about knowing those places. So, what is the furthest left digit? It starts with a 0. If it starts with a 0, it's type A. So let's do another one. Let's do a type B. And let's go with 168.120.15.7. Okay, so it's the same thing. We have the first octet is all we really care about because that's going to give us all the information we want. So we have 168 decimal, and well, what does that equal in binary? Look back up here at this chart. The largest digit we can put in there is 128, so we're going to do that down here. 168 minus 128 equals, should be, 40. Okay, so now we have a remainder of 40. Back up here, what is the next highest one? We can't use 64, we have to use 32. 40 minus 32 is what? 8. That's handy. Well, we have 8, so we're just going to subtract 8 now. And now we've reached 0. But now we can see, okay, we used 128, we used 32, and we used 8. So the binary number for this is going to be 1, because 128 is the first digit on the left. It's going to be 0, the next one, because we didn't use 64, and then it goes to 32, so that's going to be 1, 16, 8, 4, 2, 1. Now, if we look up here, we see that Class B network starts with the binary 10. Or rather, sorry, that's not 10. Keep in mind, this isn't decimal, like I just slipped up and said. This is 1, 0. And we can see here, it starts with 1, 0. So we know that this is a type B. Now, the type C is the exact same, but instead, your binary is going to start with 1, 1, 0. There's going to be something that'll give you your type C. Pretty much, if it starts with 0, there's no other option. It is a type A. If it starts with 1, you go to the next one. If that's 0, then it's a type B, and if it's type C, it needs to start with 1, followed by a 1, followed by a 0. It's pretty elementary. But we're not done yet. First of all, I'm going to flash this on the screen because this is hexadecimal. And we'll just start up here. Hexadecimal takes binary and gives a character. Now, the hexadecimal table starts out with 0 through 15. Or rather, it starts with 0 through 9 because those are the early digits, the first 9 digits. And then it goes into the alphabet. So for the first 4 octets, hexadecimal, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's fine. But then we get into the alphabet. So 9 is 9 in decimal. That's the number right there for 9 in hexadecimal. So A, that's 10. That's the 16 place. No, that's the 8 place. My bad. That's the 8 place. That's the 2 place. There you have 10. That's A. 11 is B, C, D, E, F, and it goes on. But you'll notice that F at 15 is all ones. So what do? We carry it over. So then G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. It's just counting up with binary, starting with numbers, reaching 9, and then going through the alphabet as well. All the way W, X, Y, and Z. And then it goes on. There are other hexadecimal characters, I'm pretty sure, but if not, that's whatever. Subnet masks, if you wanted to, which you can't really do this at all, it makes no sense to, and it doesn't really work. But if you wanted to, subnet masks. Oh, screw that. I'm going to cut that out. Yeah. Okay guys, hello. I wanted to show you one last thing before I finish off this vlog, and this is how to count binary on your fingers. You know, you can count in decimal with your fingers. Everybody does it since you're a kid. Okay, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 fingers. It works out fairly well. Now, this is how you count in binary on your fingers. So, just like this, each finger represents a digit. And my lighting isn't too good. Got some shadows over here. But you can easily see that's 1. 1, 0. If the finger is closed, curled in, it's a 0. If it's open, it's a 1. So the cool thing is we can just count it up, just like normal, in decimal. 1. Okay, 1. The first place in binary is 1. Okay, so close that, open the next one. That's 2. The second place in binary is 2. Okay, well, what's 2 plus 1? 3. Okay, so what's after 3? Move to the next position. I know it looks vulgar, but remember, you're just counting in binary. 4. The third place in binary is 4. Okay, 4 plus 1 is 5. Then 6, and 7. The fourth position is 8. Plus 1 is 9. Plus 2 is 10. Plus 3 is 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. And I'm not counting to 128 because that would take a while, and I kind of don't want to, but keep in mind that is 128.